Can everyone hear me?
Yes.
Yeah, so it's great to be back here. I love this meetup, not only speaking it, but being around. So the title of the session I have to present today is called Speed and Scale, Optimizing the Largest CX Platform out there, CX as in customer experience. This is me, I'm Matheus Albuquerque. I'm a staff software engineer at Medallia. I'm a Google Developer Expert in Performance, and you can find me everywhere as White Combinator. And before we start, I'd like to share a bit on the motivation I had for this session, actually. So there's this post called Silent Engineer by this guy called Vadim, and I would recommend you check it, but the beginning of the post is fairly interesting. So the output says, while browsing Hacker News, I sometimes get the feeling that every developer out there is working for a FANG, as there are always posts from those people doing some hype stuff. And then he continues, but let's be straight, that's like 1% of the developers out there. The rest of them are just lurking and coding with the language of choice and being content about it, be it Fortran, COBOL, Perl, or PHP. So this talk is not about COBOL or Fortran, but it's not about modern versions of modern frameworks or modern rendering strategies or any of these buzzwords we hear a lot these days. I do have one session about buzzwords, but you can check that later. But this talk is about some realities of the industry, especially around performance optimization. There's this classic thing that optimizing performance is just as simple as 5 steps or drawing a horse. And you begin with this, and then you just gotta add some small details, and then you fix performance of your app. I'm glad you left. That was supposed to be the funny part of the talk. Speaking of realities of the industry, so that's my industry, that's Medallia. We are one of the biggest players in the customer and employee experience. And especially the platform I work for is the service platform. So basically the thing you get when you fly with the company or you stay at a specific hotel or etc. And it's one of the main signals we have for collecting people's opinions. So in the context of surveys and Medallia, this talk is about a process of modernizing dependencies of a legacy code base. This is also about code splitting, this is about React, and doing all of that while targeting a wide range of browsers. Of course, this is also about the challenges of working with legacy code bases, a lot of experiences and lessons learned, and some of the stuff we got on our radar. So first part, modernizing dependencies. And so that you get what I mean by modernizing. So this is kind of where this specific app was. So we got some React 15, Webpack version 1, and Node 10, which doesn't really sound great, especially if we've been working with cool stuff like Next.js. But we had to start somewhere. So that place was Webpack. So going from version 1 to version 5. As you can probably wonder, there's just a bunch of benefits, and the web is flooded with posts on, for example, how people migrated from version 4 to 5 and got smaller bundles and this kind of thing. But also, once you start doing some migration, you stumble upon a lot of things like loaders not being compatible and different configuration that change it throughout different majors. So a couple of gotchas throughout the process is the first one, migration is also about having all plugins and loaders on their latest versions and ensuring they're compatible with each other. So that's not just about making sure they work with v5, but also making sure that they don't collide or they don't have any dependency you're not even aware of. Second thing is, you cannot migrate to v5 unless you're on v4. So we were in v1, so we went all the way from v1, v2, v2, v3, v3, yeah, you get it. And the third thing is there's a lot of hidden stuff. For example, Node version 10.13 is the minimum requirement for Webpack v5, but you will notice that a lot of plugins and loaders, they will require different minimums of nodes or different minimums of other dependencies. So that's something you also have to figure out. So let's upgrade Node. That was from 10 to 18 actually. So not a lot of magic going on here, but one thing that I did stumble upon was Node fibers. So if you've done any sort of migration past Node 14, you probably had to handle, maybe it was SAS or maybe it was something else, but there is this thing called Node fibers. That was one of the main ways of doing concurrency work in Node. And V8 basically changed how it works, and then Node 14 changed how it works because V8 changed it. And then a bunch of things that depended on that, like SAS, and we happen to be using SAS, also had issues. There's a whole post by the official SAS community on the discontinuation of Node fibers, by the way. But that's just another thing. What I really wanted to get into was going from React 15 to 16. And you might be wondering why this is even a priority in the first place. So the title of the talk is about performance, and it turns out that the React team across different majors, of course they work on new features and etc., but they also work on reducing the bundle size of React. And one example is going from 15 to 16, you have a 30% smaller bundle size, including React and React 9. But it's not that easy to do that kind of thing. For example, prop types. So yeah, prop types used to be a thing. So prop types in React 15, they were part of the main React package, but in the 16 major, they were transferred to a separate package. And if your application is using prop types and you want to bundle it with React 16, either you have to come up with some fancy strategy to run different versions of React in the same app, or you have to come up with a migration plan that's fancier than just finding and replacing. So I started thinking about that, and my first idea was, okay, I'm gonna find some node diffing library. I'm gonna write some specific diffing logic that can read through files and apply some diffing thing. But soon enough, I found myself writing a lot of code and not covering a lot of edge cases. So having a lot of work and just manually doing that. Then, having worked with a bit of React Native in the past, a second thing I thought about was patch package. So patch package is super popular, mostly in the React Native community, and it's basically a library that allows you to write specific Git-based diffs, and then this automatically applies this to your dependencies upon npm installation or something like that. But I didn't want to use patch package as a whole. I just needed a subset of its functionality, and it didn't really expose the subset I was looking for. Plus, soon enough, I found myself rewriting a lot of patch package itself. Then I took a couple of steps back and thought, okay, this is not the first time I'm going from React 15 to 16. Back in the day when 16 was released, I did migrate another app that I was working at the time to 16. And at the time, the thing I used was this tool by Facebook called JS Code Shift. Who here has heard of it? Okay, cool. So you can check it out. It's a tool by Facebook, and the short summary they have is JS Code Shift is a tool that runs a transformation script over one or more JavaScript or TypeScript files. And the thing about JS Code Shift is it plays really well with a bunch of open source out there that are called code mods, including the React code mod by the React team. So basically the React code mod is a set of transformations ready to be piped into JS Code Shift that will apply predefined operations to your React source code, including, for example, the prop type thing. So they have something ready to use that you can do npx React code mod, and then you pass this thing, and then the path of the file should be transformed. So that wasn't the direction I needed to follow. But at the same time, I couldn't just do this in one shot, and then, because basically I'm not doing any new feature or anything that's potentially carrying any bug, but at the same time I'm changing the whole app. I'm changing the runtime dependencies, I'm changing the way the app is bundled, I'm updating Bubble, I'm upgrading Webpack and all of that. So we need a safe mechanism to set this for different clients, and an easy regression is fallback strategy and all of that. So doing this, but behind a feature flag. That's when we start talking more about code generation. So taking one step back, basically what we're looking for to provide was, in parallel, having different versions of the developer dependencies, like Node.js, Webpack, Bubble, etc. Also different version of application dependencies, like React itself and other runtime libraries. And different strategies for bundling and serving the app, so different configuration files, different all of that. So that's kind of a snapshot of what we had. So we had this repo and we had packages, and let's call A the main package. In B, we had some functional tasks that we ran against the A package, and etc. And we went from this to this structure. So breaking it down, we had legacy A, and that was the full bundle that served. Also, that's where active development, for example, new fixes and new features were shipped. And this is the code that was pushed to the repo. And that's, by the way, the code with the legacy dependencies. So we're talking about React 15, Webpack 1, and etc. And then, going down here, we have this umbrella called Next, but not to be confused with Next.js. And this was the whole thing that was hidden behind a feature flag. And that's where the modern, so-called modern dependencies were, so React 16 and onwards. And that was mostly composed of the code transformers that were wrote to be ran by JS Code Shift, a lot of other automation scripts that would move files around and etc. And specific Webpack v5 config and other configs targeting the modern built-on dependencies. And also some parts of the code that we, in time, didn't find scalable ways to code generate in, like some unit and functional tests. And then within this umbrella, we had the actual code that was generated at build time. And you can think of that like locally or within a CI. And this included React components, utilities, business logic, and all of that. And this code was never budgeted. So we're talking about an also code generated git ignore file that had more than 1,000 lines. So running this script was like this, so you had a bunch of core tasks, and then typing a little bit more into the transformers. So if you're working with JS Code Shift or anything like that, I really recommend you check out this tool called AST Explorer. And this basically allows you to visualize how your JavaScript code or your JSX code or anything is mapped down to an abstract syntax tree. So using this tool, I started writing some transformers. That's, for example, what it generates for one specific import declaration. And the basic anatomy of a transformer is this, of a JS Code Shift transformer. So you export a function and you access the API, and here you can see that it has a bunch of utilities for navigating the source of the code. So here I'm finding variable declarations called foo, and I'm renaming them to bar, and then you can return to source. So that's a very basic transformer. So we modeled this around with transformer groups. And this was a custom abstraction, or basically each transformer group would have a label to describe what it was doing. It would have a pattern of files it was matching against, and also the path to the custom transformer or to a open source transformer or something like this. And after that, all we had to do was now iterate the different transformer groups and apply those transformers. Last but not least, something we also needed to migrate was WebDriver. So WebDriver is the tool we were using for functional end-to-end tests. So we went from version 4 to 7, and just like with Webpack, we had the same problem. So we had to go from version 4 to 5, 5 to 6, 6 to 7. But again, JS Code Shift was helpful here. So the WebDriver team, they provide some open source JS Code Shift transformers that you can run. So you have one to go from version 5 to 6, and this is going to generate, for example, a new config file, new step definitions using the new API, and they say that's it, no more changes necessary, but it was not really the case. So another thing that happened is, and guess what, because of changes on how Node works internally, and guess what, Node fibers and etc., version 7 had a whole different synchronicity API. So they also had a transformer to migrate that, but the transformer had a bunch of edge cases. So the edge cases that were not covered by the transformer, we had to cover manually. So that was it for modernizing the dependencies. And by the end of the first act, what we had were 2 versions of the same app, just one of them being committed, and the second version being generated at the same time, and they were served conditionally depending on whether you would turn on a feature flag or not. moving forward with optimizations, another thing we did was code splitting, which might sound trivial to, that's kind of the optimizations people were doing 6 years ago. But if you're not familiar with code splitting, that's kind of what it's about, where you have a huge chunk of code and then you split into smaller chunks and then you basically download and load them upon certain conditions, be it a specific router or something becoming visible or etc. Probably you've seen this done with React. As of React 16, you have lazy and suspense. So when you combine these two, you can do some code splitting in React out of the box, works mostly like a charm. And that's where we started. And actually, we were doing this by different question types, in the sense that if you as a user are not answering many different question types, there's no reason for your browser to download all of them. And we got some really interesting results splitting by question type. But just like any other performance optimization, this kind of thing doesn't come for free. So different apps will have different side effects of code splitting. The one we had was basically, as a platform, we allow customers to write custom JavaScript and custom CSS to tackle the look and feel and change behavior of what a survey looks like. And basically, when we introduced code splitting, the first thing that happened is some of the custom JavaScript code was accessing elements that were not yet plotted to the DOM. So we had to partially reverse some of these changes. But still, we got some interesting numbers. Part 3, Preact. Who here has heard of Preact? Okay, half of you. So if you're not familiar with Preact, Preact is this smaller alternative to React by Jason Miller. And the bundle size comparison kind of looks like this. Maybe you have different values these days, but we're talking about a 10 times smaller alternative. And Preact ships with what's called Preact Compat, which is something you ideally can plug in your code, and it's going to make all of your React code work like a charm with Preact. So we got really good results by replacing React with Preact in our model. But again, some gotchas. So, and the kind of gotchas you're going to have on Preact really depends on the app you're building. Most of the gotchas we got was with random side effect of rendering order of elements. And after a lot of investigation, we noticed that this was caused by pairing Preact Plan with React Lazy and React Suspense. So what we did, and that worked like a charm, was we replaced Lazy and Suspense to the way people used to do imports before, that is loadable components. And loadable components was adding just 2 kilobytes to the bond footprint, so the final trade-off was worth it. And let's talk about jQuery. So, yeah, I'm not gonna do raise your hands. I guess you all know jQuery. But one thing that's interesting about jQuery is that I took it from Wikipedia, but there should be more recent numbers. But we're talking about 77% of the web still using it. And we were not using it in this platform. But the thing is, as I mentioned, we do allow customers to write custom CSS and custom JavaScript. And guess what? People were using jQuery in our product, like tons of clients. And jQuery has some issues that, of course, the first one we tend to think about is performance and how it slows down, how it's bloated, and how all the DOM manipulation it introduces is heavy. But there's another thing, jQuery has vulnerabilities, like different versions will have different vulnerabilities and etc. But overall, jQuery is something we want to get rid of as an ecosystem there. But if that's not part of our code base, how can we even know where it is? So one effort we started was detecting jQuery with build-time technologies. So I guess most of you know Babel, but have you ever written some Babel plugin or something that uses Babel internal APIs? Yeah, two. Yeah, so Babel has a lot of interesting tools that allow you to navigate your code. One of them is Traverse. So basically we ran a lot of automation that would navigate our data centers and find occurrences of jQuery introduced by our clients. And then we used Babel, we're using Babel to run this code and detect where and how jQuery is being used. So it kind of looks like this. So imagine dozens of functions that are trying to find different possible occurrences of jQuery. For example, when you're creating a custom plugin, or when you're using jQuery to perform a fetch call, or when you're changing the styles of an element. And with the kind of insights that AST traversing can give you, we're building this kind of visualization where at a customer level we can understand which functions are being used and how we can replace them, and etc. Not only this, but we're also using proxies, which are like one of the most interesting things that came to JavaScript in ES6, and it's not enough discussed in my opinion. So we're using proxies to detect jQuery in runtime. So basically we're patching jQuery to detect its execution and then log to RUM which functions, for example, are being called, so that then you can have real-time understanding of how people are using it. And why not in the future even think about using compilers to compile jQuery code? This was a video. Yeah. To compile jQuery code to native JavaScript and native HTML and etc. So we still got a lot of work ongoing and yet to be done in this front. But that's something that also has to do with performance and has to do with static analysis of JavaScript. Anyways, I was supposed to talk about targeting different browsers, which is something that I don't think we think about enough. So I myself sometimes am surprised when I see the wide range of browsers that are visiting our apps. I'm talking like Blackberries or Nokias or Samsung proprietary browsers, or even the PlayStation browser. So when you see this kind of list, you know you want to polyfill things. But at the same time, when you run a Lighthouse, you know you don't want to over polyfill. You don't want to serve legacy JavaScript to modern browsers. So finding a balance is also key. And we have different strategies for polyfilling things. So one of them, and this was way more popular a couple of months ago, is polyfill.io. So the way polyfill.io works is it inspects your browser's UA, and it's going to basically serve a script that is generated with the polyfills needed for that specific urgent user agent. And it also allows you to pick a specific subset using their existing UI. So you can, for example, say, hey, I'm looking only to polyfill map, so it's going to find that whether that browser needs map or not. But the thing is, first of all, you might also be adding an extra overhead of processing because that's a script out of your domain. And the second thing is, you tend to be subject to polyfill.io outage, which actually happened back in summer. So basically someone took over polyfill.io domain and did a supply chain attack that hit more than 100,000 websites out there. So yeah, I was so happy I didn't use this at the time. Anyways, the second thing is you can use Bubble itself, and you have Bubble preset env. And preset env allows you to have, you have this specific thing that is use built-ins, and you have two possible values for that. So the first one is use built-ins entry. And the thing is, use built-ins entry is not really useful if you're targeting old stuff like EE11, IE11, and etc. Because you might remove some polyfills, but a lot of them will still be in the bundle and still be downloaded. And actually there are some blog posts with examples if you Google specifically for use built-ins entry. And the other option is use built-ins usage. And it's not gonna add polyfills, but the problem is it's not gonna add polyfills to your dependencies unless you pipe your node modules through Bubble, which might be not ideal. And the second thing is you might get runtime errors in the browsers because then it's a more aggressive approach, so you might be actually lacking stuff. And on the other end, you still might end up with excessive polyfilling because of this. So it's gonna, the way it works is it's going to static analyze and find occurrences of these methods. So for example, if you have array.includes, it's also gonna polyfill string.includes because it's looking for includes, and it cannot safely detect whether you need just one specific include. So it's gonna add all the includes, and something similar. So symbol.toString tag, it's gonna add also math.toString tag, and so on. And then the third option is what some people out there call differential serving. So basically, you bundle two different versions of your app and you serve them differently depending on something. So one very popular strategy to do differential serving is based on this no module attribute of the script tag. So basically, if you don't have ES6 support, it will not load anything that you mark with type no module script, and it's going to load the no module ones. And you can use this no module attribute to basically serve the ES6 polyfills to browsers that need it. So I'm not saying this works for all of the cases, but in our case, that did the trick. So basically, it works like this. So you can flag as no module, and then you download the full thing, and then anything you flag as module, it's going to be downloaded by ES6 plus compatible browsers. And that's kind of what you have. So polyfill.io is easy, it doesn't ship anything to modern browsers. If you want to use it nowadays, you now have to self-deploy it and self-serve it. The whole project is open source. Still, it might increase your TTI and FCP metrics because most of the time you're talking about something outside of your domain. The second thing is you use built-ins, but it's easy to set up because that's a Babel plugin and some Babel configuration. But either it's not very useful for all browsers, or you will have to compile your node modules through Babel as well, which might be fine for you. And then the third thing is doing this module versus no module strip that is easy, but only strips ES6 polyfills, which for us was enough. One last trick about that is you have different ways that you can do the whole module, no module thing. And the first one is the very basic example I showed you, but it has a bunch of gotchas. So this is a project on GitHub called what is differential serving? And you have a lot of tests, and the gotchas is basically, as always, browsers needed to implement things in different ways. So you're gonna find browsers that are downloading both bundles and executing both bundles, legacy and modern. You're gonna see some browsers downloading both of them, but only executing one of them. And there's one very, very interesting edge case that they're downloading both bundles and executing the ES6 twice. So you don't want to do the raw detection. You want to think of something else. Something else could be user agent detection on your server. So the moment the browser hits the server for serving the bundle, you detect in which case the browser falls in. But the gotcha here, but it's not a gotcha for everyone, but for us is you might not be in control of the server, which was the case, like the team owning the server was a different team, and they didn't want to add a whole user agent detection logic, and I don't blame him. And the second thing is, if you load a modern script without the module attribute, you might be losing some of the advantages, but that's just a minor gotcha. And the third thing you can do is, and that's what we ended up doing, is runtime detection. So before injecting, so you start with the basic script tag, and you detect whether that attribute, this list of attributes are supported or not, and then based on that, you inject the script tag to download one or the other. And this works like a charm. So that's it. For polyfilling, we went with module versus non-module, and choosing how to serving it, we went with the runtime detection. Some reasons to wrap it up. We ended up with a bunch of really, really huge PRs impossible to reveal. And these, trust me, these are just two of them, like things were a bit bigger. Yet, we had a passing unit test with not only this, but most of our manual regression and end-to-end automation and all of that was still working, which is great. In terms of bundle footprint, so for modern browsers, we're talking about a 37% smaller result, going from 280 to 177. And for legacy browsers, and I'm talking Internet Explorer mostly, we have still something that is 25% smaller. And you might be wondering, how is this line? So basically, as of September 21st, modern, we're talking about almost 96% of the web out there, and legacy is anything that is mostly pre-2018, and Internet Explorer is the highlight. And crossing this data with RUM data that's now up to date, this meant 0.2% of all the users, so everyone else would get the 37% reductions. Other metrics, most of core web vitals were improved. FCP, speed index, LCP, TTI, and all the niceties. Timings wise, we also improved, so here you can see in comparison with the feature flag on versus off. Yes, it's a slight difference, but still something. And same thing about visual progress, so feature flag on and off. Before wrapping up, a couple of things in our radar. So performance and this kind of thing is a lot about culture and tooling and an ever-living process. So we always keep an eye on things like code visual code or whatever IDE extensions, or online tools like monophobia, or anything that can help you be more aware. Also using tools that are part of our daily life but are not so popular, like Chrome Developer Tools has this coverage tab that is really helpful with spotting unused bytes of your snippets. Also, every day more and more tools comes up. For example, this is Midden.js, and the team behind Midden started as a faster alternative to React, but now the team has shifted into working into a lot of the static analysis that can spot wasted re-renders and a lot of other bad practices on React in compile time. So that's brilliant. Other things like offloading the main thread with creative solutions like Paragon, and even keeping an eye for server stuff like using better compression algorithms like that are less popular, like Broadly, Zofly, Z-Standard, Jitsi, and all of that. So they address different things. Some of them are for images, some of them are for text compression. And even using things like Quick, which is the subset of the HTTP-free spec that can reduce round trips when establishing connections. Now I'm about to close for sure. So just some thoughts, and I tend to harp a lot on this string, but I really think that sometimes understanding the internals of the tools we're working with, be it React or even JavaScript as a language, and etc., helps us implement our own abstractions in situations that demand extra creativity. So the two examples I wanted to show you here is this whole mass migration tool built on top of JS Code Shift and static analysis, and using Bubble to detect how a certain library is being used in your code base or in someone else's code base, for example, or even using proxies to patch some third-party library and detect how it's being used in your code. And I personally tend to think that a lot lives in compilers and how we see them in UI engineering. And who here remembers about Elm? So Elm invested a lot in compiler work to optimize performance, and it got a lot of traction in the first years, but then things happened. Another less popular thing was PureScript. Also, Prepag was a project by Facebook that's now dead, but Prepag also invested a lot in static analysis to optimize runtime performance. And now we have Midden in the React ecosystem, and the work that they're doing is just amazing. And not to mention, for example, Solid or Svelte, or even the React compiler that we used to know as React Forget that is now out there. And if you check the blog post, this is the blog by Satya, one of the core team members of React and the one who's mostly focused in the compiler. You're gonna see the amount of optimizations you can do in front-end UI code using a compiler. So yeah, I would definitely recommend you keep an eye on that. The second thing, and this is more about polyfills, yes, you have to ship polyfills to all the browsers your users might use, but at the same time, it's a bad idea to overship them. So try to find the sweet spot, the perfect balance. The third thing, as always, don't take fast network CPUs and RAM for granted. Not only test on real devices, but also check reports out there. For example, this is called the Performance Inequality Gap, and every year they publish, and it's really interesting to see like how different 4G or different connection speed or different devices can be in different parts of the globe. And if you're working with something at scale, you might be interested into that. The cliche is true, there's no silver bullet, so a lot of the things I mentioned here work good for us, but they might not work for you, and vice versa. And one of the things that it's super hard, and even though we try a lot to do, you end up failing, but I have to say this is try to correlate business metrics with performance metrics. Especially in surveys, this is super tricky to do, but if you can, if you have a different domain where it's easier to spot bounce rates or conversion rates or anything like this, and correlate this data with performance metrics, do that, because there's no way you can game this kind of metrics. As always, the slide for this presentation are here in this QR code, you can check it, and thank you for having me. If you have questions or anything, I don't know if
Actually, I have a question before I ask her if they have more. What was the size of the team and how long you spent on it? Because it seems like really a lot of work to do.
Oh boy. So,
and many that ends actually on the way, right?
Yeah, so the size, so I will start with the time. So these are some results of things we rolled out across different epics, let's call it that. So we had performance phase 1, performance phase 2, and so on. So one chunk of work was, for example, Preact and code splitting, and that took 3 sprints of 2 weeks, for example. And the first chunk of work, that was the static, basically building transformers and all of that, that specific part, we're talking about 3 or 4 sprints, but the whole other migration, for example, doing by hand the cases that we were not able to tackle by static analysis, for example, a lot of unit tests or other things, like we also had enzymes, so a bunch of things doing by hand that took like more extra sprints. But overall the work was split across different epics, and the size of the team, that is reflected by how the work was split. So in some epics we would have like 2 people, in one of them 1, but it's a range of 1 to 3 people. Mm-hmm. And everything is rolled out across different efforts, yes.
So it's not as bad as I expected.
Yeah.
Especially the first part looked very a lot of work actually.
Yeah. You would be surprised that actually coming with strategies at product level and like with extra paperwork to get this kind of change rolled out is almost half of the effort, to be honest. And that's something we're still working on. So it's not like, for example, all of our clients are using this. We're still working with a small EAP group and etc. So yeah.
Thanks. Very nice. Any other questions? No?
I also have a extension to the question on the business side of it. Because how did you come to this situation where you have like a deprecated code base? How old is this? So gradually, regular upgrading is always easier. Yes. So when a new version of Node is released, you upgrade like step by step, and you had some like several years old code base, right?
Yeah, so that's a question I still ask myself, to be honest. Basically, that was like the very first slide where you see, that's how things were when I got to that project. I have different theories on how this can happen at an enterprise scale platform, but I don't have a finite answer. But it's mostly basically when some platform is feature complete and doesn't have a lot of bugs, people tend to just look away and not invest in technical debt and invest somewhere else. And then when you start getting customers to complain about performance, or customers to complain about, let's say a customer runs a third-party audit and say, hey, you have this really old dependency, what is that? So when customer starts to complain, that's when business turns their eyes into focus into that again. But yeah, it's yeah.
was the last
Oh
one?
yeah, so the code base was built back in 10 years ago.
Wow.
This version of that.
Yeah.
So this version of it, and it was coming from an iteration of an even older code base that was a Java application that was converted into a React app, but it was 10 years old and just like 8 to 10 years old. That's how we're talking.
That's not that bad, so you got out of it.
Yeah.
Was one more?
I wanted to ask, do I understand correctly that you develop in the old world and in the new world as well? That you basically need to, if you want to implement a feature, that you need to implement it both in the old world and in the new one?
No, actually that was the thing where we were avoiding the most, having to implement everything twice. So for a wide period of time, we implemented only the old one, and the new one was going to be code-generated. Of course, we were not code-generating things, for example. So the limitation is everything we implemented was using React 15 technology. So new components is still used, for example, methods and the whole class lifecycle and not hooks. And they still needed to be subject to React 15 rules and not 16. But we're not implementing twice. So the moment you implemented a new feature or a bug fix, basically what would happen is the automation would go through all the files. It would work on the necessary differences like prop types and everything that was minimal enough so that you can bundle an app with React 16. And that was all at build time, so in the CI. So only one version of the app even went to Git. It's not like we had two versions in Git. We had one version in Git, and the second version only had the Webpack files and all the automation, so Groovy scripts and etc. But it was generated at build time. But we were subject to React 15 rules until we made the default version, the one with 16, so that we could start using third parties that relied on hooks, for example, and things like that. But that took more than a year. So
my question is more hypothetical, probably. So I wouldn't call the efforts that you took like conservative, because like Webpack 1.5 and other things, these are huge. But something has me wondering, like, is there a world in which you would create this automation or like code nodes or any other maybe partially code node strategy to going from React 15 to something even more modern? Do you see that and have you explored that? Still in the React boundaries, like not switching to another framework, but like in the React boundaries, but going to more modern features, like using things like suspense, but conditionally, things like that.
yeah, so if we were for some random reasons to subject to being to having to compile to React 15, then I would have to consider code generating hooks. Or one thing we discussed at the time was the opposite. So do one final migration to the modern one, and if for some reason we had to support previous versions, then start via static analysis turning hooks into lifecycle methods and etc. For example, which is super tricky and it's hard to exhaustively check this with the compiler, but that would probably be the needed thing. I was also thinking about this in the sense that now, like React Forget was initially supporting only 19, and we cannot bundle with 18 more for different reasons. And then I was thinking about that. Now that React Forget supports 17 plus with a runtime plugin, that won't be probably necessary. But yeah, if constraints were different, then I would be thinking at cross React version compilation.
Thank you.
And by the way, how extensive was testing, for example, for the polyfills and number of browsers you showed? It might be a nightmare to test all the combinations. And
Browser-wise, I would say not enough. So basically, we have automated one suite, and we ran this in browser. So at our team level, we have a suite that we automate with browser stack in a random modern browser like Chrome 120 in macOS, and then I Internet Explorer 10 in Windows, and so that's the only coverage, and then one mobile browser. Also, we have a team of manual testing, and they also build their own automations, and they also do manual testing. So for these specific cases, we let them know that they should think about older browsers, but definitely we never cover it enough, to be honest. Like, it's more like you roll it out, you let a customer know you're rolling this out, and then you keep an eye on escalations to see if people are notice bugs or something. And if you have some RUM tool, you can also keep an eye on runtime errors and this kind of thing for customers that enabled something. But that's a possibility. We didn't do that.
Were there any critical incidents after this change?
For the customers that we enabled this to, which is a fairly small subset of our total, because we have, like, using our service platform, we have more than 1,000 different companies worldwide. So for the small subset of clients we enabled this to so far, it's so far so good. And the incidents were, for example, the one, but we have a very, very strict ring deployment based process and etc. So, for example, the thing about conditionally importing things. So when I wrote that one out, a customer soon supported that their sandbox instance had something not working, and actually it was crashing. So we investigated and spotted. So we have, just like most of enterprises, a very, very strict process in rolling things out. So this prevents lots of headaches. Yeah.
Great. Thank you very much. Guys, as I mentioned, now we have a break. Let's start again in like 5-10 minutes with the second talk, and that's it. Thank you.